probability is the chance of an event occurring. For example, what is the chance I will pick a green chip from this bag? And I'm assuming that I'm not going to look in when I pull out a chip. We see that there's 3 green chips and 1 red chip. Well, in order to figure out the probability or the chance that this event is going to happen, that I'm going to pick a green, let's look at how probability is written. Probability is written, or can be written, as a fraction. And here's how we figure out what the numerator and the denominator would be. The numerator, or the number on top, is the number of favorable outcomes, or the outcome that we're looking for. In this case, picking green would be our favorable outcome. Over top of the denominator, the total number of possible outcomes. And there are 4 chips in the bag, so that our possible outcomes is 4. So the chance, or the probability, that I'm going to pick green is 3 for the number of greens out of 4, 3/4, or 3 out of 4. Let's do a few more easy examples. What's the probability that I will spin red with this spinner? Well, there are 2 red sections. Red is our favorable outcome out of 4 sections altogether. So the probability that I will spin red is 2/4, or we could simplify it to 1/2, 1 out of 2. If I was going to roll a die, the probability that I would roll an even number, well, here are all of my possible outcomes. So there are 6 possible outcomes, and there are 3 even numbers, 2, 4, and 6. So the probability that I would roll an even number is 3 out of 6, or 1/2 when it would simplify, 1 out of 2. And if I had a coin, a regular coin, the probability that I would flip heads would be 1 out of 2, because the coin has 2 sides, heads and tails, and heads is one of those choices. The favorable outcome would be heads in this case, and there's only 1 head on a coin. You have to be able to describe probability using both numbers and words. When we talk about numbers, probability of an event can be represented by any number between 1 and 0. So you could use a fraction, or you could use a decimal too. Let's look at this chart here, drawn on a sort of like a number line, and look at the numbers to represent probability and the words that correspond with it. Okay? So something that it has a 0 chance of happening, or is a 0 probability, you would call impossible. So for example, the probability that there would be February 31st in this calendar year is impossible. February only goes up to 28 days, or on leap year 29 days. So there's no way that we can have February 31st, so we call this an impossible event. Let's look at an impossible event in probability using probability manipulatives. If we had this spinner and I asked, what's the probability that you're going to spin red? Well, there's no chance you're going to spin red because there's no red on this spinner. So we would call this an impossible event with a probability of 0. Let's work our way down the number line. Here, if we had something that is a probability between 0 and 1/2, anywhere between those 2 benchmarks, we would call that unlikely. The chances of it happening, not very good. In real life, the chances of it snowing in April are pretty unlikely. It's possible that it could snow in April here in Virginia, but the chances are really small. All right, it's bigger than impossible, but less than half. And if we were talking about probability in math class, you might have an unlikely event. If you had a deck of cards, it would be unlikely that you would randomly draw one that was a face card. And the reason for that is that less than half the cards are face cards in any given deck. In the very middle between 1 and 0 is 1/2, or we can use the decimal 5/10. We call these kinds of events equally likely. Next year, when you go to 5th grade, it's equally likely that you'll get either of the teachers. You have a 50-50 chance. We say sometimes hear people say that 50-50 chance of getting one teacher or the other. So it's equally likely. If we had a coin, it would be equally likely that you would flip heads and tails because there's only 2 choices and you're going to get one of them using a coin. Anything that falls between 1/2, the probability 1/2, and 1/2, we call likely, or it's a good chance that it's going to happen. It's a good chance that on any given day we're going to have outdoor recess. We have recess outside more than half the time, and fewer than half the time does it actually rain and we have to stay inside. So it's a good chance that you're going to go outside on any given day, and we call that a likely event. in this bag, it's likely that you're going to pick purple because there are more purples than greens. And finally, we call an event certain if the probability of it happening is 1, or if it's definitely going to happen. For example, it's certain that Christmas is going to fall on December 25th this year because Christmas is always on December 25th. That's a certain event. If we were going to roll a die, we could be certain that the number that we were going to roll would be greater than 0 because all the choices on a die are greater than 0. So it would be certain that that would happen. Sometimes you'll talk about events or games maybe that are fair or unfair. So let's talk about how we can determine if something is really fair or unfair using probability rules. First, let's talk about a dice game. If I rolled a die and I was going to get points for any time it was an even number, and you were going to get points any time it was an odd number, then the chances of me getting a point is 3 out of 6 because there are 3 even numbers and 6 numbers on the die. And the chance that you're going to get a point is 3 out of 6 also because there are 3 odd numbers and 6 numbers on the die. So we would call this game fair because we have the same chance of winning. On the other hand, if I said, okay, here's the rules to our new game, I'm going to get a point for any number, and this symbol means greater than or equal to. When the sign is underlined, it means also equal to. So I'm going to get a point for any number that's greater than or equal to 3. So in other words, I'm going to get a point for 3, 4, 5, and 6. You're going to get a point for anything that's less than or equal to 2. So you're going to get a point for 1 and 2 because these numbers are less than or equal to 2. So I have a 4 out of 6 chance of getting a point because there are 4 numbers I'm going to get a point for, and you have a 2 out of 6 chance of getting a point. And of course you're going to say that game is unfair. I don't have as good of a chance of getting a point as you do. And because our probabilities are not the same, then yes, this game is unfair. Let's look at another example with a spinner. You can see here that it's broken up into 8 sections, 2 reds, 2 blues, and 4 whites. If we set up a game where I get a point for spinning blue and you get a point for spinning red, our probabilities are the same. There are 2 blue sections out of 8 and 2 red sections out of 8, so our probabilities are equal, and this is a fair game. On the other hand, if you decide to make new rules and you say that I'm going to get points for any time I spin a blue, that's still 2 out of 8, but you're going to get points for any time you spin white. Well, there are 4 white sections, so the probability that you're going to get a point is 4 out of 8. And I'll say that's not a fair game because our probabilities are not equal. So if you're truly talking about a fair game, chances of winning are equally likely. Whatever game you're playing, our probabilities have to be equal. An unfair game is any time that the chances of winning are not equally likely. And finally, one quick note about conducting probability experiments. I flipped a coin 5 times and recorded whether I flipped heads or tails. Well, you can see here in my quick experiment, I flipped heads 4 times and tails 1 time. And you might be thinking, that's not what I expected to happen. I thought that the flipping heads and tails was equally likely, so my numbers should have been closer together, not different, 4 heads and only 1 tails. Well, it's true that when a probability experiment has very few trials, like 5 trials only, the results can be misleading, not what you expect. So I tried it again, and this time I increased the number of trials that I did, and I flipped the coin 100 times. And I got, this time, 51 times I flipped heads and 49 times I flipped tails. Well, this was much closer to what I expected to happen. They're only sort of 1 off. So in summary, we can say that the more times an experiment is done, the closer your data comes to the probability that you would expect. So if you're trying to find out the probability of something happening by conducting an experiment, make sure that you do lots of trials and don't just rely on the data from very few trials.